cosine. We are performing hundreds of daily new repeated malicious binary. We see each day keyloggers, phishing, and other requests. And yes, some of them are confidential. We have an enormous quantity of malware each day, so it's clear that without automation, we could not even start our analysis and be efficient enough. Well, we couldn't even cover more than 20% of the archive. So actually, this quantity is really, really big. Just need to speak to Victor, please. Okay. Okay, what's malware classification? And what we do? First of all, antivirus agents does not detect all threats. This is a fact. In our labs, we are using more than 20 agents, and each sample that we receive, we are actually inspected using all our agents. And surprisingly, we see lately new kind of vector attacks, which antivirus agents does not detect at all. And the variation between vendors are enormous. Another aspect is that the malware algorithms tend to use code. So for example, we just heard about the new variant of the StatNet. Why? Because we believe that people use most of the time the same base of code and tend to add complexity to the code, but they pretty lazy to try and start a new brand of code. So what actually we see is we see a lot of new variants of existing family. So for example, if we used to see the configure, if you remember, so there was the configure A, the configure B, the configure C, and it was really a pain in the ass, sorry about my French, to start and understand that we are using the same code actually. So few labs around the world start using a new technique and a new idea to start to classify malware. And the reason is, first, it is going to help the antivirus vendors to improve their signature base. Secondly, it's going to help us in the security world to know when a new outbreak is starting and which kind of variation has started. And by this, we can even know if we detect the new source of the viruses. We can now understand from where it comes from, because we can understand if it's the same family but a new variant. There are a few products today that use, by the way, the slides are moving, I can't see you guys, so but the slides are going ahead. Okay, great. Okay, that's great, sorry. It's very hard. Okay, so there are a few products today that are performing malware classification. The biggest one is from Dynamics. The product name is VixClass. It's now Google. It's used same algorithm as the BigDiff. It has a huge, big signature database, and it's really intuitive. The problem is that most of the products today are using signature base. And why they are using it? Because every new malware or a new virus that comes with a malware classification application needs to be detected somehow. So most of the applications today are using antivirus at the backend to start and classify it. So it will give them a hint. So what is happening is, for instance, that when new malware arrives and it arrives with a new pattern, actually, if it does not exist in the database itself, it won't be detect anything. Oh, wait, come on. I have a problem. I see the Skype notification jumping. Thanks, Flash. Another problem is that Dynamics today is owned by Google, so we are not happy about it. Just a moment. Sorry. Another tool that we are having today is the YARA. The YARA is a freeware tool that helps us to identify binary signature and pattern. It's a static detection tool. It's a C-based program that you can write from command line, and we are using it mainly to detect. It's like a signature base. It works like an IDS. So, for instance, if you're using a packer, and I know that a video packer has its binary signature, we can detect it using YARA. Another tool by Dynamics is the BinDiff, which compare binary and using the IDA, and can help us performing comparison between binaries. Another tool that we have today is Binabi by Dynamics. Again, yes, Dynamics are really good and help us actually detect vulnerability, but also perform nice code proofing, which we can use later to do the comparison between the code graphs itself. I know that you hear my Skype, it's pretty lame, but I was going to turn off the sound now. So, how is doing the malware classification? First, we are starting with categorized and labeling malwares into families. Secondly, we are using identifying and a behavioral pattern because we know that every malware has a unique pattern. If it is coming from the same family, it's still different. So, for example, again, if we are using the configure A and compare it to the configure B, yes, we know it comes from the same variant, but it still does something else. Even if it's using the same vector to exploit the system, it still might using a different vector, might start the execution in a different flow. And the next phase is identify new variants, because if we have a huge database of malwares, and so we can easily detect when new variants arrive, and how we are doing it, because we are simply compare the binary flow to our existing database, which is enormous, and I will show you it soon. So we can assume that we detect a new variant, which does not, first, that can be part of the existing family, or it can be a new derivation of family. The categorization process helps us to distinguish between viruses, spyware, vector, trojans, and worms. Actually, it's a real buzz today, because when I was a kid and used to hack stuff, it was only viruses. But today, you know, the industry started to classify it to spyware, vector, trojan, and worms. So actually, what we see is that if someone is writing a new rootkit, so we usually refer to a program that go into the kernel, or sometimes trace your keystrokes, or writing an application that propagates and copy itself to a new computer. It's like, so we call it a worm. So actually, with the categorization process, we can differentiate between the vectors and the worms by measuring a few of its characteristics. So for instance, we would see that a worm actually try to scan the network, for instance, and try to see and try to identify a specific machine that it can be propagated. So for instance, if you have a map near a Windows machine, most of the chances that the worm will not try to infiltrate the OS 6 machine, because OS 6 is secured, but the almost probably will. Just kidding. So we can actually identify which application or which malware is a worm, or which one is a backdoor, for instance. Another good outcome from the categorization again is that we can detect new variants. So for example, again, if we went to see a worm that start to scan the network, for instance, and we start to see a new method of scanning, or a new vector of exploitation that we didn't see before, we can assume that it's a new a variant, or might even a new targeted attack. So how are we causing actually doing it ATM now? First of all, to do this, we are collecting samples. We have a huge quantity of samples which we receive in the next step that we are doing, we are using a new kind of method which we call the auto-analysis, which perform data snippets, which I will explain soon. Then we are defining behavioral of the malware, and in the final stage, we are clustering the methods. So, how we are collecting the samples? Concerning connect to our customer using what we call the virus networks. What is the virus networks? Virus networks is a secure networks that most antivirus companies are using to exchange information. It's like a VPN dedicated network that we use to get from our partner and to send to our partner interesting pattern. So why are we doing it? We're doing it first of all to help each other. Secondly, we get a new technology from each other. When I say technology, it's new malware. And usually the virus network provides us a good binary quality. The size are really, really enormous. Second option that we are using together with the samples, we are using a honeypots. In the AML, we have 8 different locations around the world, which we are using honeypots to gather samples. Now, the idea behind this, except of course, to gather binaries, that we are using different locations and we can categorize samples by location. It's true that the internet is a big cloud, but you still can distinguish in percentage kinds of samples or targeted samples that we see in Asia compared to samples that we see in North America, Middle East, or Europe. So what actually we are doing is deployed on a tier 1 level honeypots. The tier 1 is a big hosting, or big ISP, which that provided us with a good bandwidth time. And we are using two methods of honeypots. We are using low and high interactions, which means that the low interactions are actually a passive machines, which are sampling the network they are residing. So it's like a Prometheus mode, and comparing samples that are running on the wire. The high interaction modes actually are Windows machines which actually running malicious URL that we are analyzing in the AML labs and trying to fetch from the drop zone new binaries. We summarize the honeypots actually provide us 5% of our daily malicious binary collection, which is really a lot. When I will explain how much samples we get a day, so you can understand how much is 5%. The third one, and the third one is products. What are we doing most of the time is connecting to forum, hackers forum, and a lot of forums that try to analyze malwares. And we want some pretty cool crawlers that manage to connect to the forum with username, password, and download binary which people are uploading to the forum. So it's actually cool because part of the forum that we are connecting to are trying to help people to analyze samples which are very hard to analyze. So we are actually download those binaries to our lab, and then we start to perform the analysis using our framework. The connection here is pretty minimal, but often provide new mutants, which again, people did not manage to open or antiviruses did not detect, so we sometimes can find new variants inside the forum using our crawlers. And of course, the last option is intelligence, and here I don't need to add more. We do have cool guys that have a lot of connections. We show people, and sometimes we use samples that barely manage to propagate yet, and we get upper hand and manage to dissect them. So what is the auto-analysis? The problem today that most of the security world today, or most of the companies today using antiviruses, and rely only on antiviruses. And antiviruses is a good tool for people who need to feel safe. But for us, the guys who want to do the classification, AV vendors usually does not help a lot. And why is that? At the beginning, we took our AV engine, and then as I said before, we have more than 20 different agents. And we started to check the naming convention and to see if we can gather some unique methods to identify new samples. So what we agree, all of us, all the researchers, that the AV vendors does not agree on standard naming convention. Meaning that if I'm going to use some AV or a semantics antivirus as a conspiracy, I will see different naming convention. Some versions using better techniques to differentiate between small variants. So, for instance, we took two samples, two blaster of a malware, and with two different variants, but from the same family. So both of the samples were blaster, but both of them were with different hashing algorithm. Maybe one of the end we get totally different family and different naming convention. So we actually understand that we cannot rely on a specific engine to help in the labeling process. So what we did do, we used only one antivirus engine just to detect if it has malicious code or not, and it's only for the initial process, and not as any method of labeling environment. So just to get an idea, in the example, we took two legacy codes, with two different hash from the same family. We managed and we made sure that the signature will exist in all the antivirus engines. And in this example, we took like I said before, and you can see it was two different hashes completely. You could claim AV unidentified as a blaster, second variant, which is a blaster as well. It identified as default exploit, and did a better job. It understands that it's a variant of the same family, so it's detected as NS blast, trend micro as well, but we get coffee, the third, like default, and the other, which is time blaster W. So as you can see, it's not an easy task. We could not rely on antiviruses at all. We got something like 50% of accuracy and consistency, which really cannot help us achieving our leveling goal. So how actually we are doing? Daily, we are using enormous samples which are collecting and receiving each day. And this is challenging. As well as we are collecting more than 30 gig of malware a day, guys, 30 gig. Now, of course, we're using our antivirus engine just to help us to detect what is repeated or not repeated, so we don't have to deal with the same data every day. We are seeing something like between 50 to 80 new variants a day, new variants. And of course, we have to do a thematic analysis, as I said before. Not like other product, which uses a built-in signature. What we are using is the Camel framework. The Camel framework actually saves us. Why? Because it's a completely isolated sandboxing environment, which perform fully analysis of the binary, which we are uploading into the system, and provide us with the initial data set and help to do version. And this is a really important procedure inside this process. Because without it, you have to open the tools, perform disassembly for each sample, and you can see yourself what are going to be the consequences. Actually, it would be probably better to do a 10 sample daily, not more than this. So the auto analysis is a must here. What we are doing is defining the behavior several of the samples. As I said, I mentioned before, we're using the kernel. Inside the database we are using are inside the kernel and inside the AML. As I said, the sample that we are collecting is over 30 gig a day. It's really crazy. We think only one engine, just if something itself, it categorizes as a malicious. And the binary result, but for sure I'm not only ending ID, I'm not only relying on the engine, because we see that the engine does not detect a malicious. So, what we're doing is that after we are analyzing the binary with the antivirus event, we then go and check the kernel organic analysis. With this relation, we discovered test and test. We mean, essentially, what we do see is we build a unity between the various. So we of course know that it's not going to be the good method to inspect analysis itself. So what we tested in this particular just for this for our research, we took several different malware classes. We took pretty big quantity of samples. The first was the output with quantity of 80 samples. The second was the sanity malware with 60, zeros and the so on. And those were the quantities that we perform our research and try to figure out how to perform root malware classification methods. Really important to mention here that there are a few samples today that we start to see around the world which refuse to run at all on an isolated machine. And for those samples, we don't have we can't do any automatic analysis, and we do have to do some manual testing, and we can use the sandbox and auto analysis, so the story is totally different. But this is really unique, and we are not see it a lot. So in our test, we took all those 4 different malware families, and we took pretty big samples for each one of the families that we have at least variants, so we can understand how to perform the malware classification itself. So actually how we're doing. All malware are executed without user permission, so we assume they are malicious. And I explain. In Windows today, if you're using Windows 7 or Windows XP Service Pack 3, if you're not actually allow the malware to run in terms of double click, the product unless elevating exploit inside the system. So any malware, but without user ticket, without user interaction, we can actually classify it in a suspicious binary because it should not run without the user approval. Our approach is totally different from others automation methods. We have efficient free time on the cable system, which we are using as a free-scale approach. We are not using that API hooking. We're using our proprietary hard drive, which is below, it sits inside the kernel. And what we're getting like this is that most of the malware cannot detect us and cannot detect that we are using in a sandbox. It's not really a virtual machine, but we are using it inside a sandboxing machine. And the malware cannot understand that it is being monitored. We are using another method which is called DLL injection by moving the function to running process. Today, between real thousands of malware, we managed to execute more than 96%. When we checked another method of virtualization and sandboxing, the average are not higher than 25%, which is extremely high compared to others. What we are doing actually when we start to classify and define a behavior, we're starting to check the system call manipulation. We are checking which sorting driver, which technique the malware is going into the kernel. We check which registry modification and which file system modification is being made to the system. And we are also using a geolocation of the malware, or better, which are and where are the drop zones location when the malware is trying to connect. And we are cluster all those findings into a behavioral analysis. So how the initial report actually look? You can see this is a profiler of the table analysis system. It's a much more comprehensive report, so I just try to summarize it. So you see that, for instance, here, this is a PDL4. What we can see apparently in PDL4, which is what we can see is that we see a process creation. It's summarized to a write opcode, so we can see the malware is writing some code to some of, and they move to some of the application inside the system. We see the registry modification there inside the code, and we see that the malware also deletes something from our system. And of course, we see that the geolocation, which is that we are detection where the malware actually connected. So what are we doing actually? You will see in the next slide. After we get all this information, we are actually starting to categorize the behavior or define it. So what the kernel is doing for us. For instance, we see that we categorize the number of opcode the suspicious binary perform. So we see that the kernel is actually excluding the native system. So, for instance, what are the native systems? We have a whitelisting inside our machine, and we know which system of course the system usually runs. So, what the kernel provides us is, in this example, is that it categorizes all the number of opcodes, excluding the native system command. Then we can see that we have a type of opcode. Types of opcode are already categorized into a database. So here in this example, we see that we have 4, 8, and 10. 4, 8, and 10 are actually the alias for which type of opcode the malware was running inside the kernel system, inside our automated analysis. For the researcher, he has a huge aliasing, and he can, when he look at the report, he can quickly identify the type of opcode and which kind of opcode the malware executed. Then we see again the drop zone and the protocol number it tried to connect to. So in this example, we see 1, 4, and 6. So this is, we follow the RFC, meaning 1 for ICMP, 4 for IP version 4, 6 for TCP. So what actually we saw here, that the malware performed these 3 methods of connectivity. It used the ICMP protocol, it used IP to communicate, of course, and it used the TCP protocol to communicate to the drop zone itself. So what if we look at the summarize of the profiler report, we can see that actually you can have a structure here of a behavioral. What we see here that actually we have a sample. For the sake of this presentation, we have an unknown sample. This sample has 48 opcodes, which are totally new to the system. They are not using the native one. The type of opcode, which is 4, 8, and 10, are the write, delete that we saw, and the registry modification. And they are the same. It's important to mention that what we are performing inside the kernel, we are excluding, we have a whitelisting, so the false positive will be much, the chance